Hello and welcome to Retro Circuits. In this channel I talk about retro computers, how to program them, tinker with them and also review retro video games. In this episode I'm going to try to bring back to its original glory this joystick, which is my original joystick I used to play when I was a kid. It is dirty, faulty, dusty, but I really care about it. All this dirt accumulated here is a valuable piece of archaeology of 80s garbage. My plan is to put underwater and soap all the plastic armor for several hours. Meanwhile, I will remove all the cabling inside and replace it with new, fresh one. The mechanics of this joystick is interesting and quite simple. As you move the handle, there is a spring that pushes this lid into the contact, making that characteristic metallic sound. As you can see, the board is very dirty as well, but we will fix that in a moment. For the internal cabling, I'm going to use these silicone electrical wire cables. The link is below. And for the main cable, I bought on eBay a joystick extension. The plan is to cut it and use the rest as a replacement of the original one. The color of the cables are of course different than the original one, but that shouldn't be a problem. We can map each cable to the corresponding color. The way to accomplish this is very simple. You take a multimeter and then you set it into continuity. Take one of the ends of the multimeter and connect it to the socket in one of the pins. And then with the other one you check the cable. When you hear the beep, it means electricity is passing. It means that that pin corresponds to that cable color. Let's review a little bit how the connection works. On the left, you have the connector on the Commodore 64, and on the right there is a table corresponding for each pin what it means internally. These two pins are not important for us right now because they are for a paddle, they don't work on a joystick. These numbers here correspond to the memory locations that read from the joystick port, for the port 1 and the port 2. These numbers are available in the port's memory locations above, and they represent each direction and the fire button. By using the command peek, we can read these values and take any action we want in our program. Finally, this pin provides 5 volts, but it can only deliver 100 mA, meaning that you can power any electronics your imagination can think of as long as you don't exceed that limit. To clean the board, I use this 99% alcohol. In reality, it is a little bit less than 99%, but it should do the job. Another way to clean the flags is by using an ultrasonic cleaner. The good ones are quite expensive, and unless you need to clean tons of dirty PCBs, maybe it's not worth the investment. Remember that this pure alcohol is very flammable, so be careful and make sure you have no fire sources nearby. Time to wash the other parts with a little bit of soap and fairy. And in case you're wondering, no, this is not my own toothbrush. Back to the studio, it's time to put everything back in place. You can see that the original cable has a little hook to keep it in place. It adds that little extra protection in case someone pulls the cable. I don't have that on the new cable, so my plan is to remove this from the original cable and glue it to the new one. Some time has passed and I updated a bit the studio. I managed to get an overhead camera view. Personally, I prefer it, but let me know in the comments what do you think. Unfortunately, I didn't have the right glue for the job, so I improvised a bit and used this glue for food. I'm not happy with the results. It's really dirty, but it is what it is. Maybe I will change these in the future, but fortunately it is not that visible. At least I'm really happy with the results for the board. It came out pretty clean. Now let's check the notes we took matching the right colors with the original cable, and let's proceed to solder every cable into the board. The original cable had some clips which made the replacement of the cable easier. In this case, we don't need that. Everything is in place, And now let's proceed to check that the right cable is connected to the corresponding pin of the socket. In order to check that each direction matches the right color and the right pin, we set the multimeter to measure the resistance. This joystick has some electronics inside and we only want to see if there is some electricity passing through. I'm also very happy with the results of cleaning the joystick. It came out pretty nice. Be careful here when you push this part because you can trap a cable there and break it. Time to test it on the real Commodore 64. The easiest way to test this is by writing a very simple program in BASIC. This program basically shows on the screen the values contained in the memory location corresponding to the joystick port. When we move the joystick, the values will change and match the ones in the diagram showed previously early in the video. There is a little issue here, all the directions are working but the fire button. I probably made a mistake. Let's open it again and find out. The issue was very easy to fix. I forgot to make the connection to the ground. There was no way the fire button would work. Back to our Commodore 64 and it's all working, all the directions and the fire button as well. Now let's take a view of the joystick in its full glory. Let me know in the comments if you have a similar joystick like this one or if you try to do a similar restoration process with it. If you like this video, please give me a thumbs up and remember to subscribe. Thank you and see you next time.